Hi everyone. I see a lot of people already here, so yep. Thank you for joining, and I believe like you already given the contest. Also, let me know if you can hear me properly. Can you once let me know in the chat if you guys can hear me properly? Once let me know in the chat if you guys can hear me properly. Okay, awesome. Uh, So let's do one thing. Let's get started with the problem statement. Also, how many were solved, able to solve all the problems, and also let me know like which one did you face difficulty with, and yeah, we'll discuss all the problems and we'll try to solve them. Right. So let's start with the first one. So the first one is you are given an integer n denoting the number of people who needs to be seated, right? So and you are given a list of m integer seats where 0 represents a vacant seat and 1 represents an already occupied seat. Find whether all n people can find a seat provided that no two people can sit next to each other. All right. So we are given n people and we are given m integer seats, right? Okay. uh, all one. Okay, 2 3 were difficult time taking. All right, we'll see if they were like we'll try to solve them as well, right? So we are given an integer n which denotes the number of people who are seated, who are to be seated, not seated at all. And there are m seats. The seats are represented as binary numbers 0 and 1, where 0 represents if the seat is vacant and 1 represents if the seat is not vacant, right? Like someone is already seated there. So you have to say whether we can fit all the n people within the seats provided that no two people are sitting next to each other, right? So we have 0 0 1 0 0 0 1. This is the seating arrangement that we have, and we have two people. We have to seat two more people, so we can place one person at 0, one person at index 4, and in that way we can like get all the people seated, right? Now here we have to seat one person, and we have three seats, and we have 0 1 0. In this case we cannot make any person sit anywhere, right? Like if we make him sit here, the person cannot like this person will be blocking this person, so the answer will be no in this case. So we have to print whether it's possible or not possible, right? So the only condition being two person cannot sit next to each other, nothing else is the condition, right? That's the only condition that we have. So there was a problem. The task was not seating is already sitting, people can already be sitting next to each other, where okay, next to each other, kind of sitting next to, which broke my brain. Yes. So again, like that is actually evident from the second test case, right? Like I also didn't understand if we can make a person sit to like already seated person, or like should the end person not sit next to each other, or even the people who are already sitting, they're also not allowed to sit next to each other. But if you see this example here, we have 0 1 0, right? And the answer is false. So here one person is already sitting and we have to sit one more person, right? Now wherever we make this person sit, it will be next to this person who is already sitting. So in that case, that's why the answer is no, right? So from this it is pretty clear that actually the people who are already sitting, they also matter, they also will have to follow the same rule, right? All right. So let's understand this. How do we solve this, right? So okay, it's reversed. I'll just make this straight. Okay. So we have a few zeros. Let's say 0 0 1 0 0 1 0 0 0, right? So what we can do is we can search for a greedy way to place the people, right? So we have to place n people, and we can try a greedy way to place all the n people. How we can do that? We can start from the first index. Like we'll check if we can place a person here. Yes, we can, right? We can place the person here. So it's better to place the person here, right? So we'll just place the person here in this place, in this position. So let's place a person here. Next we go to one index 1, and we can check zeros between non-occupied seat and took cell zeros, but it didn't work. Okay, let's see if this works. Actually, I'm also not sure if this will work. So we have a zero here. Here can we sit a person? No, right? Because we have to go at least 2 places away, because we cannot make the person sit next to this. So we'll go here directly. Here it is already seated, so we'll go to next. As already seated, we'll go +2. We'll come here. Here can we sit a person? On the left hand side it is vacant, on the right hand side it is not vacant, so we cannot make the person sit here, right? So we'll go to the next cell. This is already booked, so we'll go 2 cells away. So we'll come here directly, and here we can sit the next person. So here it will make it 1, and then we'll go to the next cell, and we'll go 2 places more, and we see that it has come to the end. So we see that we cannot sit more than 2 person here, right? So if n equals to less than equal to 2, in that case this would have been yes, otherwise this will be no. We cannot make 3 persons sit in this arrangement. So that's what we can do. Actually, we can do a greedy like solution where we start from the first we'll start from the first cell. We'll check if we can make the person sit here, right? So if this cell is vacant, there are 3 conditions actually. First is cell is not vacant. So it is not vacant, like it has already been taken. If it has been taken, we'll just do I plus equals to 2. Why I plus equals to 2? Because if a person is sitting here, right? If a person is sitting here, he cannot sit here. The next person cannot sit here, right? He has to sit at least 2 seats away. That is this seat, right? So not vacant. The second condition is what? The second condition is if the person, the current seat is vacant, but the person cannot sit here because it is blocked. Like let's say this seat is vacant and the next seat is 1, or the previous seat is 1. In some case, vacant but cannot sit. In this case, we can go just by I plus equals to 1, right? Why I plus equals to 1? Because see here in this case, if we go I plus equals to 1, we go to a seated position, and from there we'll go I plus equals to 2. So this will work here. Let's say the seat before was booked and this is currently 0. In this case, let's say the next seat is also 0. In this case, we might actually miss on the next seat, right? We might actually miss on the next seat. So we should move by 1 step and see like here if we can get it seated. So let's say this is a valid one, so we can get a person seated here. So that's why I plus equals to 1. And the third is vacant but can sit. Vacant and can sit. Can sit. So in this case, we'll get the person seated here. So n minus minus, 1 person is seated, and I plus equals to 2, right? I plus equals to 2. Why? Because you had a 0 here, you are placing a person here. So in the next seat, you cannot place a person. The next position you can place a person is plus equals to 2. So we'll directly go to plus equals to 2. Right, so I think that should work. And again, like there might be cases like in the already seated situation, as someone pointed out, there might be something like 1-1 or something like this. So we have to be careful about these things as well. Like there in any of the existing places, two consecutive seats are not already booked. In that case, also return false. Right, and we can just take this up separately as a corner case, I believe, and the rest we can do it in a greedy approach. So let's get this done. So let's go to this, right? Okay, let's see if we can do this. So we have m seats available and vector in seats, right? So bool is, or rather let's do it like this. Finally, like when we come to this position, we'll just return true, and otherwise for int I equals to 0, I less than m minus 1, I plus plus, and inside this we'll check if seats of I is equals to 1 and seats of I plus 1 is equals to 1. If both are equals to 1, that means this is an invalid arrangement, like 2 persons are sitting next to each other. So we'll just return false, right? We will just return false in this case. Next, what we'll do is we'll go again greedily for int I equals to 0, I less than n, I less than m, I plus plus. All right, so first thing we'll check is if seats of I is equals to 1. If seats of I is equals to 1, we'll do I plus again. We'll do I plus again. Why we'll do I plus? Because in that case here we'll do increment I by 1, and again when the loop ends, the I is incremented by 1 again. So we are essentially doing I plus equals to 2, right? So here we are incrementing I by 1. and when the loop is ending, it is again doing I plus plus, so I is incremented by 2, right? So that's what we want to do. Like when the seat is booked, we want to increment I by 2, so I plus plus, right? Else, if it is 0, right, if it is 0, there are two cases possible. First is if it is a valid seat, right? If it is a valid seat, so what we can do here is we can check if a seat is valid. So bool is valid, and or rather we can check it here as well, I believe. Else, if it might be a lot of conditions, let's separate it out. So bool can place here, can place, let's say we have a can place method where we take a index, the seat number, int m, and the current arrangements of seat, vector int ampersand seats, right? Okay, here, now one thing to note here, we do not exactly have to update our seats. Like when we place someone, we do not exactly need to update our seating arrangement here, because we always go by two, we'll always go by two places, right? So we'll make sure that because of us, when we are placing someone, because of us, it is not actually affecting anyone else, right? In fact, if we come to a booked seat, I'm just thinking, if we come to a booked seat, uh, we cannot book if there, right? I don't think we need to be that, we can just make the condition a bit simpler. So if, right, if I is less than m, I is less than m minus 1, and seats of I plus 1 is equals to 1, in that case return false, right? In that case return false. Otherwise, if that's not the case, probably we can sit here, because yeah, like we probably can sit here. So return true in the other case. So return true. So if can place, can place and index is I, m and seats. If we can place, then we'll do n minus minus, and also I plus plus, because we'll directly go by two places, right? N minus minus and I plus plus. Else, if we cannot place, then we'll we'll do just continue, will not do I plus plus, right? Will not do I plus plus because the next seat is probably booked, so we just want to go there and then go by two places from there, right? So that should be it. I believe this should be the condition. And here, if n greater than 0, return false, right? If n greater than 0, return false, otherwise we can return true. So I think that should be it. This code won't work for this test case. 170 111 170 111 these should work, I believe. This we'll test it out, right? We'll test it out as well on your test case, because n should be greater than 0, like 170 when it's 170. I have forgotten to use index. I was not declared in this scope. Where was I? It should be index. Yes, I have forgotten to use index here. So it should be index, and yep. N equals to 1, m equals to 7. Oh, okay. N equals to 1, m equals to 7. All right. Let's see if this is working for your test case. N equals to 1, m equals to 7, and we have the arrangement to be 0, 1, 1, 1, 0, 0, 0. All right. So plus 2 from here. Just give me a second. 0 we cannot place here. Probably we cannot place here, right? So we go plus 1 here, plus 2 from plus 2 will go here. No, this will directly return false, right? This should be false, because 3% are sitting. I'm getting no, maybe the expected. Let's check the expected as well. Oh, expected is yes. Oh, so someone said like if they're already sitting, that should not be that should be false. In that case, yeah, like it will not work. So I thought that's the case, right? So let's just remove this. So if two-person are already sitting next to each other, then in that case that doesn't matter as long as we can place the last person. So in that case these things will change a bit. Wait. So in this that case these things will change a bit. What will change? And also here and index. Okay. So 1 second. So index is less than this and this, and index is greater than 0. Index is 0 or okay, index is less than m minus 1 and index plus 1 is equals to 1, return false. And yes, and index is greater than 0 and seats of index minus 1 is equals to 1. Seats of index minus 1 is equals to 1. So if anyone all of these conditions, this should be or, I believe, in if any one of these conditions is true, right? If any one of these conditions is true, that is the next seat is booked or the previous seat is booked, in that case it should return false, right? So if the previous seat is booked or if the next seat is booked, sorry, this is the previous seat and this is the next seat that is booked, in that case it should return false, otherwise it should return true. Now yeah, like if even if we go like to a place, let's consider the conditions here, right? Let's quickly consider the conditions here. So we have something like, let's say 1 0, we are at this index, this will be taken care of, like we'll just let's say here is a 0, we'll just go to this and see if this is a valid place to keep it, right? Another case can be we are at 0 1, this is anyways taken care of, I believe. 0 1, and if there is, yeah, I think that should be okay. So let's actually run this now. Expected output is yes. My output, it should be yes, it's yes. And can it fail for cases like 0 1? I don't think so. In the last also, if there's a 1 0, that it should not fail there. For I less than m, yeah, I think this should be good. So let's submit, or it might fail. Oh, it's solved. So this code is working. So yep, we can just check for the two places, like the previous one and the next one, and then return false if it's not a valid place to keep. And after that we have the similar conditions, only the fact is like if two people are already sitting that next to each other, that doesn't matter, like you should not care about that. Only the new persons that are getting seated, they should not be seated next to anyone, right? So for I equals to 0, we'll check if it's already vacant, if it's already booked, we cannot keep the person in the next seat as well, so we'll do I plus equals to 2. So I plus equals to 2, like here plus plus and again here plus plus, so it will be I plus equals to 2. And otherwise we'll check if we can place someone here. If we can, then we'll do n minus minus, because we are placing a person here, and we'll do I plus plus, then I plus equals to 2 basically will happen, right? Otherwise we'll just continue, that is we'll just go to the next seat I plus plus, and we'll check again like if that's a valid seat. So that's please explain can place function once. It's not very difficult. What it's checking is if we have a seat, what it checks here is let's say we are at a index like this, we have some 0 here, we are at this index, and before this there is a 1, right? Or after this there is a 1. In this case we cannot make the person sit in this 0, right? Because we can only make the person sit in like he cannot be next to anyone else. So that's what it is checking. It is if it is less than m minus 1. Why less than m minus 1? Because we are checking index plus 1, so we should be careful about the boundaries, right? And if index plus 1 is equals to 1, that is this case, right? In this case or index is greater than 0 and it is not this case as well, 1 0, like we are at this 0 and the previous seat is booked by someone, and since index minus 1 is equals to 1, in that case we'll return false, otherwise we'll just return true. That is, we can place the person here, that is, it's something like 0 0 0, and we are at this seat, right? We are at this seat, so that's what it's checking here. Yep, that's the first question. It's a simple greedy, like we are trying to place at every position. So let's go to the second one. Okay, so we are given oh, this is the second question. Okay, so we are given a list of strings S. You have to find the string, from the list which is a substring of S with the minimum difference of k, with minimum difference k. Here difference means the number of different characters. You can only do operations on string list I. You can rearrange the characters of the list. Okay, so right, so here if we compare, right, CDF, right, so what we are doing here is, so it's told that we are given a string S and we are given a list of strings, right? We have to compare the list of strings, like the list of strings are definitely they might be bigger than S, but mostly we'll compare like only the ones that are smaller than S, because we are trying to get substrings of that similar length in S. So we'll compare CDF with some substring of A, B, C, D, E, and we will find the minimum difference k, that is how many characters are difference with that with that substring, right? So for CDF we'll compare with CDE, right? We'll compare with CDE, and this will be the minimum difference in the number of characters that is not common between them, right? Like F is not there and E is there, so difference is 1. So CDF and CDE, the for CDF it will be 1. Similarly for EFD and ABCDE, that will be 1. That I think that should be 2 or something, right? Or for KLDA it will be 2. So like that we'll see, and the minimum difference we get out of them is 1, right? So the minimum difference we get out of them is 1, so the answer will be 1, right? So the answer will be 1. So we have CDF, EFD, KLDA, EAF. Our test cases is wrong. That might be the case. Question is, which substring of string S we have to choose? That's a good question. It can be any substring, right? So we have to compare like CDF. First of all, we have to compare CDF with ABC. Then we have to compare CDF with BCD. Then we have to compare CDF with CDE. Like that, whichever gives the minimum difference in the number of characters that are not present, in the number of characters that are mismatching, only that will be returned, right? And also note one thing, you can rearrange the characters of the list, right? So we can rearrange means, just consider the example of EFD. When we compare EFD with CDE, we get a difference of 1. Why? Because we'll just rearrange this to FDE. We'll just rearrange if EFD to FDE. Now we compare with CDE, only character difference is C, right? So the difference becomes 1, right? So the expected output will be 1. We have to like that compare with all the ones, and out of them whatever is the minimum value that we get, that we have to return. So for this we got 1, for this we got 1, for this we get 2, for this we get 2 again. So the answer will be 1, the minimum of them, right? Problem is not clear for the case when len of S is len of list of I. Why is it not clear? Like there's nothing to be clear, right? It's pretty simple. You have a substring. See, it's pretty simple with this fact that let's say we have some string, right? A B B C A, and you have a substring something like A B C, right? You have A B C, or A B, right? You have a substring like, let's call it A, right? ABC. Let's say ABC. You have this ABC and you have to compare this with ABBCA, right? So what you do is you compare all the substrings of similar length. So what are the substrings here? You will compare ABC with ABB, that's a substring, BBC, BCA. These are the three: ABB, BBC, BCA. These are the three substrings of the same length as ABC. So you will compare ABC with each of them. Now there is one thing that's given to you, that you can rearrange the characters of ABC. You can rearrange the characters of ABC. That means you do not have to compare them like this, that ABC, A matching, BB matching like this. You do not have to compare. You can rearrange them, right? So for ABB, will not rearrange, right? We'll keep ABC and we see the difference is 1. And we cannot get a better difference than 1. For BBC, we compare ABC and we see a difference to be 1 again, A and B. For BCA, however, we'll rearrange this ABC to BCA. We can rearrange ABC to BCA, all the characters. So we see that the difference here is 0. So for ABC and this string, the difference will be 0. Like this, we'll do it for all other strings of the list, and finally we'll report the answer as the minimum that is available. Right? Make sense? So we can rearrange from the list, right? We can rearrange list of I. That means it is no longer a substring comparison or a string matching. It's rather character matching. If all the characters ABC are present in BCA as well. If all the characters are present, all the characters of BCA are present in ABC. B is present, C is present, A is present. So that's why the difference is 0. Right, let's see this next test case maybe. ABC. Okay, ABC, I think there might be a problem here. ABC, why is there a problem? AB is directly matching, so the output will be 0. AB is directly matching. AB is directly matching, so the output is 0. Right, AB is directly matching. You do not even have to rearrange. So that's why the output is 0, right? So you have to find the minimum for each of them, and out of them you have to then find the minimum. It's not just the minimum of each of them independently. Find the minimum difference with all the substrings there, and then find the minimum out of them, whatever is the answer. That's the answer, right? Make sense? Time complexity will come to that. Time complexity, we will try to optimize that. But is this part clear? Why is this 0? The test cases are fine. The sample cases are fine. This is 0, this is 1. Okay, check for, you are giving two strings, EIKWBE, EIKWBE and EIKSBZ. EIK are the same. 1 2 3 4 5 6. 1 2 3 4 5 6. Okay, I don't think it will be 1, right? Because W and E are mismatching, and here S and Z is there, so it cannot be 1, it should be 2. It should be 2. Could be a single character A, B, B, C. Yes, substring can be any character, right? So substring will only match with the same size. So you will treat like whatever, like let's say list of I right now is AB. So you will only consider substrings of length 2, right? You will just consider substrings of length 2 and compare them with AB and find the minimum difference. Code output shows 3. AIK, this one, it shows 3. Let's see. I think we can check this out. Let's take one. We have EIKSBZ and EIKWBE. Let's go for expected output. It's giving 2. Expected answer is 3. कैसे 2 दे रहा है? कैसे तुमको 3 मिल गया? It's 2. Chalo, we'll see if there is a problem with the expected judge. I'll get a wrong answer. We'll see then, right? But let's solve it. Let's understand how to solve it at least, right? We'll see if there is a problem. So I think now it's clear that when you compare, right? So whenever you're comparing, let's say a substring of S, let's say ABC with BCA, the output should be 0, right? Because you can rearrange BCA. That means you are comparing only the characters, right? If all the characters of ABC, that is A equals to 1 times, B equals to 1 times, C equals to 1 times, matches with the characters in BCA, that is B equals to 1 time, A equals to 1 time, C equals to 1 time, and it does match, so that's why the output is 0. So now we know that if we have a substring, right? If we have a substring, if and we are comparing with some list of I, right? If we are comparing with list of I, we will not compare this substring with the list of I, rather we'll compare the frequency of the characters, right? We'll compare the frequency of the characters of the two of them, right? And this also frequency of characters, we'll compare this frequency of characters between them, and we'll check if the frequency of characters is valid. So that's how we'll compare the two substrings. Now coming to the complexity, right? How do we make this? So what is the complexity now? If we do in a brute force way, we are going through all possible substrings, that's n. All possible substrings, n substrings will be there, rather n minus k. Then we are for each of them we are running through for a complexity of order of m to compute between them, and then into the size of list, that is size of list, something like that, right? So this is definitely not optimal. So what we'll do here is we will try to we'll definitely try to improve on this. Now this is where the optimization, and it's a very common optimization that we do. What we have to do is we see that initially, let's consider a string here, a b c b d a c b c a. Initially we are considering this substring abc. From there we are moving to bcb, or let's consider substring of length 4, right? 3 is like with 4 you can understand better. So initially we are considering the substring abcb. After that we are moving to bcbd. So what is exactly the difference happening? This is going out, this is coming in. A is going out, D is coming in. Next iteration we are going to C and we are going to A. Again B is going out, A is coming in. So we already know our approach for this, right? Whenever we are considering all windows of size k, we know an approach to do this optimally using sliding window. So we will use the sliding window approach to generate all the substrings. We do not need to generate the substring, we just need the frequency of the characters, right? So whichever character is going, frequency of the character that is going, let's call it out character, we'll do it minus minus, and similarly frequency of whichever character is coming with, let's call it in, we'll do in plus plus. That is what we need to do. So we just need to update the frequency using a sliding window approach, right? So with the sliding window approach, so we'll generate all the substrings using the sliding window, and then we'll compare the frequency with the current frequency of the list item, right? Frequency of list of I, and we'll check if the frequency is same. In that case we will proceed. If the frequency, like, we'll find the difference and we'll update our answer equals to min of answer comma frequency difference, right? Frequency difference. So yep, so mean of answer comma frequency difference, right? So that's what we'll do. All right. Okay, there might be some glitch, I'm not sure about that. That might be the case, I'm not sure about that. But anyways, let's focus on the solution, right? There might be some issues in the contest, I'm not sure. So the logic is clear. Now what is the complexity when we do a sliding window? So whenever we do a sliding window, it becomes order of n, the total length, into, for each of the window, what we are doing, we are generating, we are not generating the frequency, rather we are just like comparing the two frequencies. So into 26 into the total number, the size of the list. So that becomes n is 1000 approximately, into 1000 into 26, right? So this is well within our bounds. So that's why this time complexity will work. So this time complexity will work. So let's go ahead with this implementation of this s and vector string list. So okay, so what we'll do is int answer. Everything can be different, so maximum answer can be h dot size, like all the everything is different basically. List dot size. For actually we do not need this anyways. For string s belongs string t belongs to list, we'll go through all the elements of the list one by one, right? String 3 belongs to list, and first of all we'll generate the frequency, right? First of all we'll generate the frequency 260, and here we'll take m equals to t dot size. Please explain time complexity in more detail. Sliding window, let's just read about sliding window. Let me write the code, you will understand like what's the time complexity. And if you don't understand, you have to read about sliding window. I'll not be explaining like how sliding window works in details, right? So int m equals to t dot size, and then for int I equals to, first of all we'll compute the frequency of t, I less than t dot size, I plus plus frequency of int of t of I minus a plus plus, right? So frequency is done, and first of all we'll compare the frequency of we'll compute the frequency of first window. So for int I equals to 0, I less than m, I plus plus frequency of int of s of I minus a plus plus. So it will be frequency of s and frequency of t, frequency of t and frequency of s, frequency of s, right? So we have the two frequencies for the first window. Also we'll maintain another private method maybe, that is int find frequency difference, find frequency difference, right? So that will find the difference between the two frequencies, right? That will find the difference between the two frequencies. So vector int ampersand frequency 1, vector int ampersand frequency 2, right? Okay, so int answer equals to 0, for int I equals to 0, I less than 26, I plus plus, answer plus equals to abs frequency 1. Not sure if this will work, we can definitely compare between frequency 2 of I and return answer by 2. Like every difference should be counted 2 times, one because of one because frequency 1 will be high, one time because frequency 2 of some other character will be high, because there's some mismatch, right? So everything should be counted 2 times, so we'll return answer by 2. I hope this works. Is vector list same as list in Java? Yes, it's same as array list in Java. So frequency int of s of I minus a plus plus, and now we'll do go start from the next window. We'll use the sliding window. I equals to m, I less than n, I plus plus. So which is outgoing? Outgoing is I minus m. So frequency of s, and also we'll update our answer here. Answer equals to mean answer, and find frequency difference. Like we are comparing with the first window, and so here we'll have frequency of S and frequency of T. First window and frequency of S of int of S of I, S of I minus M is going away, I minus M minus A minus minus, and what is coming? Frequency of S of int of S of I is coming, so S of I minus A plus plus, and we'll do answer equals to main answer, find frequency difference of frequency of S and frequency of T. And finally here we can return answer, right? We can return answer. So that should be the code. Let's try to run this. I'm not sure about if this should work. I believe this should work, but let's see. Okay, our output is 0. I think it should not be 0, or should it be 0? Like, which one is this? ABC. Not sure if this should be 0. Let's compare. We are getting 0, and expected is okay, expected is 0. So let's take the output from here. It should be 1. So let's take 4 CDF EFD KLDA EAF, and here we have ABCD. Expected output, it should be 1. Yep, it should be 1. And what's our output? Let's see. It's 1. So let's try to submit this. Okay, it's okay, it's not updated yet. Yes, it should be 2. EWKPEI. Okay, no, it should not be 2. It may be 3. Let's see. Okay, EWK, okay, BEI. So EWK BEI and EIK SBZ. Oh, we have not. So this will be valid if T dot size is greater than S dot size, then we should continue. If T dot size is greater than S dot size, we should just continue. But that should not be the case here. 1 2 3 4 5 6 1 2 3 EIK SBZ. Okay, what's the difference? E is there, W not matching, K is matching, B is matching. Yes, it should be 3. It should be 3. Somehow it's not 3 for us. No, this is not glitch. This should be 3. Because W is not matching here, then K is matching, B is matching with this, E is matching with not matching with anything, second E, and I is not matching with Z. So it should be 2. It should be 3. Ideally, I believe, if I'm not calculating wrong. So let's see why our code is not working in this case. EIK SBZ EWK PEI. Let's print my output. My output is printing 2. Why is it printing 2? Let's see. Only one string will be there, and I think there will be only one window. So M is 6, so it should be okay. I equals to M, and okay, let's have a method called print frequency. Int print frequency, sorry, void. So let's just print the frequency table, right? So vector int frequency, and for int I equals to 0, I less than T dot size I plus plus, T of I equals to 0, I less than M, that's T dot size I plus plus, frequency of S S of I minus A plus plus, find frequency difference, frequency is T, I equals to M, I less than N, I plus plus. Okay, EWKBEI, let's write it down somewhere and once check, like run through our code on this. I think that was a different output that was given to me, right? I don't think I said 2 for this. I think that was something different. EWK BEI and EIK SBZ. Okay, see, E is matching. Okay, 1 second. I is also matching. There's something wrong here. EWKBEI. Okay, E is matching. I is also matching, right? I is also matching. W is not matching with anything. K is matching. B is matching. And this E is not matching. So what is not matching? E is matching. E is matching. I is matching. K is matching. S is not matching. B is matching. Z is not matching. It should be 2. No, it should be 2. My bad. Yes, answer should be 2. I calculated wrong. It should be 2, but it's giving 3. So yes, I think the test cases are wrong. We have to update the test cases. That's fine. Yep, we need to update the test case. The test cases are wrong. Sorry. I'll ask them to update the test cases. Yes, it should be 2. It should not be 3. So the test cases are wrong. Anyways, I think you understood the problem, like how to solve the problem. That's important. And the complexity, again, like the complexity, if we run through this is the outer loop that's running. This is like order of the size of the list, right? It's going through all the characters. After that, let's say the element, we have M, so it will be this is a sliding window that's happening here, so it will be order of N plus M. N is the size of S, right, and M is the size of T, so into 26. So because we are comparing like the frequency difference for 26, so it will be N into 26 into the size of the list. What will happen for the second D will not be matching. It's not, the problem is not about the second D, right? The problem is not about the second D. The problem is about, I think this I is not being matched. So see the matching. E is matching, K is matching, I is matching with this I, and B is matching. What is not matching then? S and Z. These are all only not matching. So they will not be matched, right? So the output should be here 2, not 3. Yes, the output should be 2, not 3. So the question is indeed wrong. Is something wrong here? Okay. The answer should be 2. So for the case 1, A, B, C, D, E, A, D, where is A, B, C, D, E? Dude, read the question. Where is AD, by the way? A, B, C, D, E, A, D. A, B, C, D, E, A, D. Where is AD here? नहीं और एक्सप्लेन नहीं करेंगे, एक बार आप फिर से वीडियो वापस देख लो. Given string is okay, we're taking a case. Okay, let's take your case. Yes, the output is wrong. Output is wrong. Let's take your case again. Your case is A, B, C, D, E. A, B, C, D, E, A, D. A, D is what? the list, the string in the list, right? And s is this one. If that's the case, then ad, it should be it should not match, right? Only one, like it should only be one, because you can rearrange ad to da. You cannot rearrange this. And if this is t and this is s, then the answer should be 2, because there is no substring of length 4 here. There is no substring of length 4, right? So you can only compare between substrings of that similar length. Some, I'm not sure how they have done it, right? But yeah, like for this case I believe it should be 2, if I'm not reading the question wrong. Here difference means number of different characters. Okay. I think I have, okay, that might be the case. My bad. So I think the question is not clear. They should have made this clear. But again, I believe yes, it's actually EWK BEI and EIKSBZ. EIKSBZ. So the number of different characters, if you see the number of different characters, it's actually, it's not just differentiating on the frequency, but rather if the character is present versus not present. So if you see here, E is present, I is present, E is present, I is present, which is the given character, by the way. The given string is EW. Okay, this is given. Okay, let's see. E is present, I is present, K is present, 3 characters are present, S is not present, B is present, Z is not. Still, it should be the same thing, right? It should be 2 anyways. B is present, right? So it should be anyways 2. I am also not clear with the question. I think for this it should be 3. It should be 3, not sorry, it should be 2, not 3. Like E is present, I is present, K is present, B is present. 4 are present and 2 are not, 2 are different. In that logic as well, this should be true. So I think it should be 2, not 3. Anyways, let's leave this for now. All right. So let's go to the last problem. Right. Let's go to the last problem. So the problem is, you are given a list of intervals, of n intervals. The ith element SEP denotes the starting, ending, and the profit P earned by choosing the ith interval. Find the maximum profit one can achieve by choosing a subset of non-overlapping intervals. Right. So so we have intervals given to us, right? We have intervals given to us and some profit with them. So it's something like we are given some intervals like this. These are some intervals, right? Let's say there are some intervals like this, and each of them has some profit associated with. We need to rearrange characters only once. भाई क्या बोल रहे हो? मुझे भी समझ नहीं आ रहा क्या बोल रहे हो. You guys are confusing me more than the question. It is said that, clearly said that you can rearrange the characters of, you can do only one operation on string list. Okay, we can do only one operation on the string list of I. So we can do, you can do only one operation on the string. We can do only one type of operation, right? Which one will we operate on, that's completely on us. So we are operating on each of them independently. Or are you saying that you can rearrange the characters, right? You can rearrange the characters, so it's same. We can rearrange them, we can decide on which one we want to rearrange, but again, like, we can rearrange each of them and check the difference and then decide that this is on which we want to rearrange, right? I'm not sure like what you are getting at from that. If you have solved the problem, let me know how, like, what is the condition that you have used here, or like what am I doing wrong here, and then we can have a conversation. but otherwise you are just confusing everyone. Anyways, for this, let's say there's a profit here, profit of 10 here, there's a profit of 2 here, there's a profit of, let's say, 5 here, this has a profit of 3, this has a profit of 9, something like this. So what we have to do is we have to maximize our profit, right? So we can choose this 10 plus, we can choose this 5 plus, we can choose this 9, and we have to make sure that the intervals that we are choosing are non-overlapping, right? They are non-overlapping, that is, the total profit will be 10 plus 5 plus 9, and they are indeed non-overlapping. We cannot choose 5 and 2 together because they are overlapping. If you see, there is an overlap between them, right? We can cannot choose 5 and 3 together because there's an overlap. We can choose 2 and 3 together, so we can in fact do 2 plus 10 plus 2 plus 3 plus 9 as well. That is also a valid way to choose the intervals, right? And that would actually give the same result. But let's say this is not 3 but 2. In this case, it is better to choose the 5 over the 2, right? It is better to choose the 5 over the 2. So that's the question. You have to maximize the profit, but you have to make sure that you are not choosing two intervals that are overlapping with each other. All right, so that's the question. How do we solve this? So definitely, like, we have to maximize, and we can choose from intervals. So first of all, what we'll do is we'll sort all the intervals. Right? First by their L values, that is the left sides, then by their ends, that is R values or their ends, and after that with respect to P, that is the profit, which is not important. So let's say it's sorted something like this: 1 2 3, and it's 5. After that it's 2 to 5, and it's 4. After that it's 4 to 6, value is 5, and 5 to 8, the value is 6, and let's say 7 to 9, the value is 10. So we have this, right? So we have this in sorted fashion. Now let's say dp of I. What is dp of I? dp of I is the max value, max profit. dp of I is what? dp of I is the max profit we can get, from I to n. From I to n minus 1, that is from index I to n minus 1, what is the maximum profit we can get by choosing intervals, right? By choosing intervals. So dp of I is the max profit I can get by choosing intervals from I to n minus 1, right? So dp of I, so let's say now we are at the ith interval, right? This is I, let's say we are at the ith interval. With the ith interval, let's call it start to end or L to R with some profit P. With the ith interval, what we can do? We can do two things, right? We can take it or we will not take it, right? We can take it or we will not take it. So these are the two things we can do with the ith interval. If we take the ith interval, right? If we take the ith interval, what is the next interval that we can choose? The next interval that we can choose, see, all these elements are sorted by their L values, right? And then with their R values. So definitely this interval ends at R. This interval ends at R. The starting of the next interval should be greater than equal to R. The starting of the next interval should be greater than equal to R. So that is L next should be greater than equal to R, and it is sorted with respect to increasing order of L values. It is sorted with respect to increasing order of L values. So we can binary search to get the L next. What is the first index which is greater than equal to R? What is the first L which is greater than equal to R? That is from where we can choose. So we'll binary search on the left value to get the first index where L next is greater than equal to R, or the L value is greater than equal to R. Let's call this as next index. After binary searching, we get next index. So what is dp of I? dp of I is equals to dp of next index. We can take it plus the profit, because we have taken I, or we will not take it. In that case, dp of I is just equals to, will go to the next element, next index, dp of I plus 1. So and plus there is no profit, so the maximum out of them, right? So the formula now becomes dp of I EP is equals to max of dp of next index of I plus p comma dp of I plus 1. And how do we find next of I? Next of I is equals to the first index, where, so next of I equals to first index j, let's call it first index j, where L of j is greater than equals to R of I. First index j where L of j is greater than equal to R of I, and we can binary search for this. We can binary search for this j because it is sorted. Like we have, first of all, we have sorted with respect to we have sorted this entire list, so it's sorted with respect to L values, right? So we can get L of we can get the first index. What is confusing here? If you see, first of all, we have to do dp, right? How do we think about dp? You can there's no like straightforward way to think with this, like this is a dp solution. What you have to do, like whenever you have something like maximize or minimize, you can do either of two things. You can either do a ad hoc or a brute force or a greedy algorithm, or you can do a dp. So in our case, if we go for a greedy algorithm, there's no way for us to choose, like how do we choose the intervals greedily, right? There is no way for us to choose that. You can just definitely think about that, and you will see that there is no way, right? So the only way down is dp. So when we come to dp, what is dp of I? dp of I is what? dp of I is the maximum profit. dp of I is the maximum profit we can get from ranges or interval or intervals in the range I to n minus 1. That is what we had given n intervals, right? We are given n intervals to us. This is the n minus 1th interval, nth interval, 0 to n minus 1. Now dp of I, let's say we are at some index I. dp of I means what is the maximum profit we can get from I to n minus 1. Using the intervals I to n minus 1, what is the maximum profit we can get? Now with this ith interval, we can just do two things, right? We can either take it or we will not take it. Now if we take the ith interval, what is the condition? We cannot take a overlapping interval. So the next interval, let's say we take some other interval j, we have taken I and we take another interval j, right? So what is the condition? I and j, intervals I and interval j should not overlap. This is the condition, right? I and j are we are going left to right. Yes, we are going yes, right to left. Yes, we are going right to left because this has to be computed before we are computing this, right? We are going right to left. Yes, ij should not overlap. Intervals I and j should not overlap, right? Intervals I and j should not overlap. That means, what is the condition? They should not overlap. The L value for j, the left, the starting point of j, L means starting point, or let's call it start. The starting point of j should be greater than equal to end of I, only then it will not overlap. Only then it will not overlap. That means we have to find the first index. We have to find the first index j, after which, so we are sorting, see, we are sorting all the ranges with respect to their L values, right? We are sorting all the ranges with respect to their L values. So we can binary search as it is sorted with respect to their L values, and we have a condition here that we want to find L of j greater than equal to some value, we can binary search. We have a sorted array and we want to find which is the first index which is greater than equal to some value. We can binary search, as simple as that. So we can binary search and find the first index which is greater than equal to value. Let's call this the next of I, next index of I. So dp of I is equals to the minimum, or sorry, maximum. We want to maximize, either we take it, so it will be next index of I, next index of I, because that is the first index from where we can take next. We cannot take before that, right? Otherwise there will be overlapping intervals, and we have taken the ith interval. Next of I, plus we'll add the profit to this, profit of I, or we will not take this, so we'll directly go to I plus 1. We can try taking I plus 1, so that it will be this recursion, right? So it's pretty simple. All right, let's go ahead and write the code for this. Okay, sort intervals dot begin intervals dot end. Int n equals to intervals dot size. Int dp n, right? Int dp n. Okay, let's keep it n plus 1. dp of n equals to 0 for int I equals to n minus 1, I greater than equal to 0, I minus minus, and finally we'll return dp of 0. Right, we'll finally return dp of 0 is the answer. So we have to write a method, int find next index, and right, so we have the vector, we'll pass in the intervals here. So vector int, we'll pass the reference intervals, and int value, or int r, right, int r value. So we have to find the first interval which is greater than equal to r. So int answer equals to n by default, and will return answer. So n means like if there is no interval which is greater than which has their L value greater than the R, right? So in that case we'll return this answer, right? Now what we'll do is we'll do a binary search. Also we can do a controlled binary search. We can definitely like, we know that it should be on the right hand side, so we can do a controlled, or we can not do a controlled as well, that also works. So low equals to 0, high equals to n minus 1, both will work because it is sorted. So we are sure that, like, although here, see, when we are at dpi, we are definitely referring to all the indices from I plus 1 to n minus 1, right? We want to search on that range, so we can do a controlled binary search here. Like, instead of starting from 0, we can start from I plus 1, but again that doesn't matter because it is sorted with respect to their L values, right? So definitely on the left hand side we'll have smaller L values, so it doesn't matter whichever you want to do. So while low less than equal to high, int mid equals to low plus high by 2. If intervals of mid of 0 is less than is greater than equal to r, in that case this can be a candidate answer. So answer equals to mid, and high equals to mid minus 1 will set, else low equals to mid plus 1. So basically we are continuing our search for better values, right? We are continuing our search for better values, and we are setting it to answer equals to mid, because this is a valid value, right? Because intervals of mid of 0 is greater than equal to r. Otherwise we are continuing and for this it is less than, so our search space should be on the right hand side. So that's what we are doing. So int next index equals to find next index intervals and r is intervals of I 1, that is r, So we have found that. Now dp of I equals to min of dp of next index plus vector int lr vector int and intervals. Where is the profit? Okay, vector int and it should be lr and like that acp. So it should be vector of vector. It should be three values. Okay, it should be three values. Basically, it should be three values. Two, one, and plus intervals of I two, comma dp I plus one, and we want the maximum, not the minimum, right? So maximum, and yep, return dp of 0. So let's actually try to run this. N was not declared in this scope. That's oh, n was already declared in this scope. Okay, so that should be the code. Oh, n was not declared here. That's fine. Intervals dot size. Intervals dot size. So let's compile and run. High equals to n minus 1 int n equals to intervals dot size, and here it should be answer equals to n. Where is Java code? You can get that in the solutions, right? So the output here is 8. Let's check it out with the like, let's see if that is correct. So let's see the expected output for this. I think it is 8. This was the case that it ran on, right? So it's 8. All right, let's try to submit this. I believe this should work, but let's see. If this doesn't, we'll debug. Oh, it's working. So yep, so this is working. Any doubts on this? Anyone has any doubts on this? Any doubt with the code? It's pretty simple, right? Like first of all, you're sorting the intervals so that we can binary search. After that, dp definition is simple. Like if you, what is the maximum profit you can get from the range I to n, if you choose intervals from the range I to n minus 1. And after that, you basically like whenever you for any interval, you can either choose it or not choose it. If you choose it, you have to find what is the next interval that you can start choosing from, and as it is sorted with respect to their L values, and the condition being that L should be the starting point of that range should be greater than equal to the ending point of this range. So you can binary search on that. So that's what we're doing here. We're binary searching for the next index. That's from where we can choose, and then we are like doing a dp of next index plus intervals, like we're adding the profit here, comma dpi minus 1. Why bs? Once run for second test case. Sure, let's run for second test case. This should work. Let's see. We have 3 and we have 1 4 4 2 3 7 2 2 4. Let's okay, we are seeing the expected output. It should be 7 and our output should also be 7. Okay, output of online judge is 11 and it's given 7 here. So why is it given 7? Let's see, 1 4 2 3 2 2. Okay, so we can choose 1 4 2 3 2 2. We can choose 2 2. We can choose 2 3 because 2 2 is ending at 2 and 2 3 is ending at 7. So 7 plus 4 is 11. 2 3 7 for a profit of 7, right? So basically, like I have understood, like this question is a bit weird. So is if it is overlapping, if e1 less than equal to s1 and s1 is less than S2. Non-overlapping if E1, see, this is the condition, right? If E1 is less than equal to S2. Right. So this should be 7. Like as per the definition, it's giving 7 as per the output. But if you see the definition here, two intervals are said to be non-overlapping if E1 is less than equal to S2. If you follow this logic, so E1 ending 1 is less than equal to S2, the starting point, right? 2 is less than equal to 2, so we can actually choose them. Although technically, like 2 to range doesn't make any sense, right? 2 to range doesn't make any sense because we are kind of choosing that it should end at 2, like it should end at an index before 2. But yeah, like by the definition, either like, yes, by the definition should have been made a bit clearer, like E1 should be made less than S2, or they should not have given a case like this, right? That I completely agree with. But by the definition, it's actually 11. It's actually 11, right? Because you can choose 2 3, you can choose 2 2 as well. 7 plus 4, the definition again being E1 is less than equal to S2, right? So E1, that is 2, is less than equal to 2. So they should not have given this test case, basically this sample case, or they should not keep test case like that. That I completely agree with. But yeah, like the condition is given like that. Anyways, I believe we have done all the questions. Again, like I understand that these things are bit messed up. But again, like I didn't have a lot of hand on this, so I'll definitely like convey this to the problem setting team that they should be a bit careful about these things. But anyways, I hope that the next contest we do not have any such problems. I'll try to make sure about that. So yep, thank you guys for joining in, and I'll be seeing you in the next class. Bye.